Today we're going to be learning about matter. Now, we ask ourselves, what is matter? Matter is anything that we can touch, anything we see, anything we breathe, anything that's made up of molecules is considered matter. The air, water, this blackboard right here, computer, you, me, everything that is considered matter. In us, matter, we have molecules. And depending upon the energy level of that matter will depend upon those molecules. We'll talk about that later, but let's talk about matter right now. What is it? Well, generally we've been taught that matter is typically going to be three forms. We've seen it in the forms of solids, liquids, and gases. Solid would be something like this whiteboard right here. Liquid, water. Gas, the air we breathe, the oxygen that we breathe. There's another one that people don't normally know about. We'll learn about this in a later lesson. But plasma. And plasma is an ionized gas, and it is able to produce enough energy to be considered, to be called matter at this point in time. The three we're going to be focusing on, though, however, is going to be the solids, the liquids, and the gas. Now let's look at what we're going to be using. We're going to be using a block of ice. The ice is a solid, it can also be a liquid, and it can also be a gas. And how we determine whether it's going to be a solid, liquid, or a gas is going to be how much air to the molecules and to what makes up water. Now we know that water is considered H2O. There's 2 hydrogen atoms, and there is 1 oxygen atom. When it's cold, all the molecules are very close together, okay? And being a solid, they are touching, but they're not moving very much. It's like when you go out in a cold weather, and everybody wants to huddle together and try to stay warm. Well, molecules will do the same thing. However, as things heat up, that will cause the matter to change forms, because at that point in time, as things heat up, the molecules within the ice are going to start moving faster and faster and faster. As it gets warmer, they start moving faster, trying to get away from the heat, if you want to look at it that way, or saying that it's now hot enough, we don't need to be so close together. So they're going to start moving all over the place. You can see this in this diagram right here. Cold molecules, they do move, they are stationary, they are touching, but they're very, very slow and they stay close together. As a matter of fact, there's only one time when they would be considered not moving, and that's when it gets really, really cold, which is what we call absolute zero. Absolute zero, if you look at it on the Kelvin chart, is going to be 0 degrees Kelvin, or, and how we know it, minus 459 degrees Fahrenheit. Really, really cold. At that point, molecules will cease to move, and they will stay frozen. Okay. As we heat things up, as we add energy, this is what will change matter. This will affect matter and cause it to change forms. We will add energy. In this case, we're going to use a lighter, and the heat from the fire from the lighter will add energy to the molecules in the ice, and we will watch it go from a solid to a liquid. Now, as we said, what we have for our tools today, we have our blocks of ice. I've got a little plastic container around the ice to hold it. We do have a lighter that I'm going to be using and to provide the energy, the heat that we need. And so what we will do now, let's go ahead and conduct the experiment. And one last thing we need, I've got paper towels right here. I'm going to go ahead and put those on the floor, sort of catch any drippage. So, here's our ice. We know it's made up of water, so 2 hydrogen atoms and 1 oxygen, H2O. What we're going to do now is we're going to add energy to it. And we add energy by providing a source, in this case is a lighter. And when we light the lighter and we get the flame, then what it's going to do is it's going to provide energy. It's going to provide a source of energy to the molecules within this. And just like when you eat a lot of food or you give yourself energy, you become very active, you feel like you need to move around more. Well, same is true for molecules. So what we're going to do, we're going to take this, and I'm going to hold it right under the ice. And we see very quickly, you can see it against my shirt here, it's really starting to make a big change. It's dripping, it's getting hotter. The molecules on this end are starting to move faster, start moving in separate directions a lot faster, and that's causing the matter to change its form. It's changing from a solid to a liquid. Very easy experiment to do. And we see that it does change. Now, that's controlled and only using a little bit of energy. We didn't use a whole lot at this point in time just to make this some point. We don't want to make a big mess on the floor. Now what happens if we do add a lot of energy, if we add a lot of fire to it, a lot of heat, we put it over a hot stove, or we have a bigger flame, or a whole bunch of lighters or matches underneath this ice? Well, what is it going to do? Well, we're giving it more energy, it's going to melt. If we continue to do it, it's going to cause the solid to go to a liquid, which we showed, and then it's going to go into a gas form. We call that evaporation. All right, what happens when, if you see puddles on the ground, when it gets too hot, well, the heat from the sun, as you have a puddle on the ground, is giving energy to the water. It's giving energy to the molecules within the liquid, or within the water, and it's causing it to evaporate. It disappears, turns into a gas, goes up into the sky. And then as we continue to get more moisture in the sky, we get clouds and everything like that. So, if you read right here, less energy for molecules when they are cold. As heat is applied, more energy is given, and the molecules move faster, causing a change in the matter. Now, we briefly discussed prior to get your thoughts, kind of what do you think, are a couple of questions. What do you think will happen to our matter and why? And it's pretty obvious when you use ice and fire. You know, when you've got hot and cold, it's going to cause the cold ice to melt. Okay, so we don't think that our initial hypothesis or guess on that part is going to be any different. Okay, that's going to be a pretty well-known fact at that point in time. Now, some of you, we took a vote, and if you could take a picture of what the molecules look like in the ice before we apply the heat to it, what do they look like? And you know, you get varied results depending on just kind of what you know. But this is going to be typically right here what we're looking at as far as what do the molecules look like. Now, what do they look like as the heat is being applied? Well, it's going to be kind of in between these. All right, we're going to start getting a little more space in here. They're going to start kind of moving a lot faster. They get a little more energy, so they're going to start moving that way around. And then when it turns into liquid, the water is obviously going to be very much warmer than what the ice was. Remember, the ice is below 32 degrees Fahrenheit, or 0 degrees Celsius. As it heats up, even 33 degrees will cause that to melt. It takes a little bit longer. The warmer it is, the faster things go. That's why we talked about having more energy. You know, more of a heat source for this will cause things to change faster. Okay, so if it's 85 degrees out, then everything's going to melt a lot faster than it would be if it was 30 degrees. It'll still melt, just take a lot longer. So from here on out, you have your questions. What I want you to do is kind of go through, check your answers that you had from the beginning of class. And remember we did these questions prior to this lesson because we had an unbiased thought on your feelings and kind of what you thought before we did the experiment, saw the notes and everything else like that. And then I want you to answer these questions now and compare your answers. What changed, okay, before you had a hypothesis? All right, we're using scientific method here. We had this hypothesis, we conducted an experiment. Now we're collecting data and we're going to put it together and we're going to see if our hypothesis is true, if we can turn it into a theory, or if it's just going to stay a hypothesis and do we need more changes, okay? Well, we did a lot of this experiment, so what I want you to do now is take your questions, write your answers down, the before and after, kind of look at everything, compare the two out, and see, how do they change?